Hi, so this is 2.2. Basically, this is dealing with polynomial functions. So when we talk about polynomials, that word poly just means many. So once we get past like quadratic functions, cubic functions, quartic functions, basically anything like 2 degree and higher, meaning that the exponent is at least a squared or higher, then we're talking about a polynomial. So in polynomial functions, specifically what we're going to be doing is finding zeros. So one thing I want to really touch on is that zeros of a function is said in many different ways. So when we try to find zeros, that is the same thing as finding solutions to the function. It's the same thing as finding the factors, and it's the same thing as finding the x-intercept. So all of these four things, are equal, right? So if you're at any time asked to find x-intercepts, you use the same kind of process. Vectors, solutions, zeros. You use the same methods in order to find all four of those things. So I could interchange zeros with factors, solutions, x-intercepts. And this is important because later on, like if I tell you to graph something, you can find x-intercepts by using their factors or using a function solutions or their zeros. And having the knowledge that those are all interchangeable is really important. So the first one that we're going to be finding the zeros of is f of x equals x cubed minus 12x squared plus 36x. So one of the biggest things is we have to remind ourselves of factoring, okay? Factors are the same thing as zeros, so I need to be able to factor this function in order to find its zeros. So let's think back into ways that we can factor. If I factor quadratics, I have that method where I find two things that multiply to be the end number and add to be this inside number, but that's for things that are squared. This is cubed. So then I keep thinking, okay, what do I have for cubed? Well, I always kind of like to start with greatest common factor. So if I look at x cubed, negative 12x, 36x, the one factor that I'm hearing every single time is x. So what if I factored out an x? When I factor something out, it's the same thing as dividing each term by what's been factored out, right? By that greatest common factor. X cubed divided by x is x squared. Negative 12x divided by x, oh, this should be an x squared, sorry. Negative 12x squared is 12x. And 36x divided by x is just 36. So now I do have a quadratic, right? I have an x squared. So what I can do is find two factors. The factors have to be something that multiply to 36 and add to negative 12. So my first instinct is 6 times 6, okay? And you could make up a whole list of factors of 36. But I'm seeing right away, if I use the two factors 6 and 6, those two multiply to 36, but they add to positive 12. So what if I made this negative 6 and negative 6? Okay, multiplied together, they're still positive 36. Added together, they are in fact negative 12. So I leave this x on the outside. And whenever I factor using this method, we start with an x in each of these binomials. And then I put in the factors that I use. So it's negative 6 and negative 6. So when I'm trying to find the zeros and I factor this out, it's kind of like setting this equal to 0. Okay, so I take each one of these factors individually and I set it equal to 0. I set x equal to 0, x minus 6 equal to 0, and x minus 6 equal to 0. So going through, x equals 0 is 1, right? I'm solving for x. I add 6 to both sides, and I add 6 to both sides to give me x equals positive 6 and x equals positive 6. So all of my zeros would be x equals 0 and comma positive 6, and that would be my answer. Okay, I'm going to go through one more. This is nothing that you haven't seen before. Okay, we've done factoring like in algebra 2, factored, set equal to 0, solved for x. But let's get used to some of these factoring styles. So we're going to do another example. Okay, this example is find the zeros of f of x equals x cubed minus x squared minus 2x. Okay, so, it should be an x cubed. I said cubed and I wrote squared. Okay, x cubed. Oopsie. There you go. So, again, my first thought is I always want to try to see, is there a greatest common factor that I can factor out here? So let's try that. X cubed, negative x squared, negative 2x. Again, the main thing I'm focusing on here is I have an x as my greatest common factor that I can pull out every single time. If there was a coefficient in front of these two variables, I would try to find a greatest common factor with that coefficient as well. There's not, so I stop there. The one thing I can pull out is an x. I can only pull out an x because that's the smallest amount. I can't pull an x cubed out of just an x, so I go with the smallest amount of x's. What's left is x squared minus x minus 2. Okay, so then I keep thinking, and I think, well, what other factoring can I do to this? I have to decide, is there factors of negative 2 in which those factors would add up to negative 1? So the only factors of 2 are 1 and 2. So how can I make one or both or something of these negative in order to multiply to negative 2, add to negative 1? So let's try this as a negative 1. Negative 1 plus 2 is positive 1, but they do multiply to negative 2. So let's switch to the negative and put it in front of this 2. 1 times negative 2, negative 2, 1 plus negative 2 is negative 1. So those are in fact my factors. So again, I set up two binomials, x is in front. I still have my x that I factored out. 1 positive goes in one binomial, negative 2 goes in the other binomial. Set the whole thing equal to 0. Take each individual part and set those factors equal to 0. And then solve for x. Here, I already have that factor because I have x isolated. Here, x equals negative 1. And here, x equals positive 2. So my running tally of zeros. You see that still? Barely. My running tally of zeros is 0, negative 1, and positive 2. So you might be thinking, okay, again, what does these zeros mean? Basically, I'm going to show you the graph of this function on my graphing calculator. So let's graph this. X cubed minus x minus 2x. Oopsie. Okay, so let's see. This is what the graph of the function looks like. So we said that we have zeros at 0. So what this means is I should be going through the x-axis at x equals 0. So look at my function. X equals 0 would be right there in the middle. I am, in fact, going through at that point. So that is a 0. X equals -1 should be a 0. -1 is right over here. It's a little bit fuzzy, but you can kind of see I'm going through the x-axis at -1. That's a 0. The last one should have been at 2. Okay, I'm going through the x-axis at 2. So this is what we're saying. A 0 is a solution. It's a factor. It's a x-intercept. And it's also, what haven't I said? 0, solution, factor, and x-intercept. Okay, so looking at my graph, I can see them. When I factor and solve, I can see them, right? When I'm finding solutions to x, when I'm looking at my graph, all of these things tell me where x is equaling 0, or my y is equaling 0, or that I have zeros or solutions to my function. Okay, we're going to do one more that's a little bit different. So finding zeros, this is basically it. You have to factor and to be able to set parts equal to 0 and solve. So another thing that we like to find is minimums and maximums. What we also call these is extremas. So not only do we find minimums and maximums, which is super obvious, I would say. Basically, this is a maximum, this is a minimum, right? Way down here is the lowest point, way up here is the highest point. We also find what's called relative maximums and relative minimums. So erase this thought and look at the following graph. Oh, sorry, took a turn for the worst. Okay, so I have two different lower points and two different higher points. So at this point, I have a relative maximum, maximums, minimums, and minimums. So basically what we're saying is that it may not be the highest point of my entire graph, okay? But looking at from here to here, okay, all the points that are on the top of my pen, relatively to the points around it, this is the maximum point, okay? Not the maximum of the entire graph, but maximum of the points that are relatively around it. Same thing here. It may not be my lowest point of my entire graph, but relative to the points around it, it is the lowest point of those. Okay, so our task is to find what these points are. Okay, we call those our extrema, or those relative maximums and minimums. So we don't do this by hand, we do it on a graphing calculator. So if you don't have your own graphing calculator at home, you can Google search it. Okay, so if you do like a quick Google search of like graphing calculator, something will pop up. Another one that you can work with is called Desmos.com. Okay, that's also an online graphing calculator. But if you look at this one and like you don't love it, just go ahead and Google search online TI-84 or whatever graphing calculator. You'll find loads of them. You can also get apps on your phone that are free. You can get ones that you pay for, but you can also find free ones. But you need one for this exercise. Anyone in person, I have a whole 30-person set for you to use. whatever you need. So we're going to find the extrema of f of x equals negative 2x to the fourth plus 2x, I think, cubed. Squared, sorry, not cubed, squared. Okay. So what we do is we go type this into our y equals. Okay, so on our calculator, I don't know why you can't see this very well. Let me grab up my flashlight, see if that'll help. Oh no, that makes it all even worse. Nope. Okay, so you can see where I'm pointing for buttons though. Oh boy. So on my graphing calculator, this y equals button, okay, what I'm going to do is go ahead and type into it negative 2x to the fourth plus 2x squared. Okay, it should look like that in your calculator. And then we go ahead and we press graph. So while it's graphing out, I can kind of see what's happening, but not very well. So I want to zoom in. So I go to the zoom button and I go down to zoom in and I go ahead and press enter. Right way down here, go ahead and press enter. One more time, enter again, and then it's going to zoom in for me. The reason I do this is I need to know what's happening here. So I'm going to kind of graph. It's not going to be accurate whatsoever, but I am coming up, coming down, going up, coming down. And these two are even, so that was it. Good, okay. So in my head, where I'm seeing extrema is up here, down here, and up here. So I need to find those on my calculator. What I do is I go to the second button and trace. And then I go down. The first one, visually I can tell this is a maximum, right? That's a higher point. So I'm going to go calculate its number 4 maximum, and then I hit enter. So what happens is this little spider pops up. Okay, that's what I call it. You can kind of see it in the middle. What I need to do is this spider needs to come to the left side of that maximum. So I use my little arrows and I take him all the way over to the left side, anywhere on that left side, and I hit enter. So you should see right bound question mark pop up. That means I need to take my spider guy to the right side. So I use my arrows and I arrow over to the right side of it, but I don't go too far. And I hit enter again. So now you'll see guess pops up right there. Guess question mark. We don't guess, we press enter one more time. Now you can see this point pops up. You have an X and a Y coordinate that pops up. Mine is, obviously we were calculating a maximum. Mine is negative 0.707 and my Y is 0.5. So that's one maximum. Okay, now what I'm going to do is I'm good there. I'm going to go calculate this minimum. So exact same process. I go second trace down to minimum and I press enter. Now I need the spider guy on the left side of that minimum. So I take him down to just about right there and I hit enter. Now it tells me to go to the right of it. So I move him over to the right side. Right there is good. And I press enter. It tells me to guess again. Enter one more time. You see more coordinates pop up. So again, my spider should have been on the right and left side. So this is my minimum is And here's another thing for you. I'm getting negative 1.09 e to the negative 6. What this means is e to the negative 6. If it's a negative, I move my decimal place left 6 times. If it's positive, I move it right. So this decimal should be moved 1, 2, 3, 4, 5, 6. So this number is actually 0.000, wait, 5 zeros negative, sorry. 50109. And then my y value is the exact same. So kind of idea, 2.376 e to the negative 12. So I move my decimal point left 12 times. What I know is that I should have 12 zeros in here. So I'm going to write this number down. It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 decimal points, or 11 zeros. 2, 3, 7, 6. Okay, that would be my minimum. What this is saying is it's just an incredibly small number. Looking at this number, okay, negative 0.000000109 or 0.02376. Those numbers are super, super close to 0. Okay, you might be getting just decimals a little bit differently, and that's okay. What I'm going to tell you is this number is rounding to the 0.00. So you can call that minimum 00. Once we're that close, go ahead and round them. We have one last point to find. Go ahead and do that second trace again. This time it's another maximum. Make sure you have that spider on the left and then on the right. This next maximum is 0.707, again, 0.5. So this was a symmetrical graph here. The minimum here is equal to the minimum, or the maximum here is equal to the maximum on my right side, okay? So always, 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 when we're trying to find maximums and minimums, or extrema of a function, you use this process with a graphing calculator. So again, let me move it up there for your maximums and minimums. And then that is all for today.